You have to apply just now what all we discussed. No, those ideas have to be applied here. This is the best problem. I'm testing your ability to analyze. Look at the where is the hole? Hole is made at a certain depth. Small area of cross section of the hole is A. Depth of the vessel is capital A. Yes, anybody? Somebody was asking any doubt? Okay, the liquid here, V1 will write it. Velocity of Flex. This will be velocity of Flex. The block should be moved with a certain velocity. That's what the condition given. Let this range be X. So let the hole be located at a height H is equal to, later I'll substitute that value. Let the depth of the hole, let it be Y. These are some assumptions is what I'm making. I think I'll take the next diagram. No. So let's get into, so this will be velocity V1, velocity of the block. That's some assumptions will make it. So first we'll get the velocity of Flex. What is velocity of Flex? Straight away, shall we write 2gy, velocity of flux will be 2gy. Then what is the range? It will descend in the height h. So h is equal to g t square by 2. What is capital T? The jet, that one. Time taken by the jet to move from hole and strike the block. This is a time of flight. So therefore this will be T equal to 2h by g. Can now get into what is the expression for range? This range should be equal to v1 into t. So v1 is how much? 2gy. This should be 2h by g. G gets eliminated. So this will be root of 4yh. Keep this in mind. What's be the velocity of the block? Dx by dt. What will be the velocity of the block? Dx by dt. So what is x? X we know. So 4yh. So here derivative of root of 4. Okay, this 2 also will come outside. Yh. Derivative of 2 root yh. So h is a fixed, no? H is not variable. Y is variable. So therefore I'm going to differentiate this one. So this VB is equal to 2 root h you take outside. So derivative of this will become 1 by 2 root y dy by dt. To also get cancelled. So we'll finally end up with root of hy this should be the speed of the block, but we don't know h we know, y also we know, but we don't know dy by dt. Am I right? We don't know dy by dt, how to calculate. Say what will happen to as the liquid continuously flows out, what will happen to level of liquid in the container? Should decrease, will agree. I think you need some set of diagram to really understand this. What actually going on? This is the thing. After some time, what is the state of the let me extend the diagrams. Or I'll show it below. I think I'll help you with the diagram. So the container will not move. Container will be there only. The hole is made. With the time, what will happen to level of liquid? This will be the situation. The level of liquid will be decreasing. You can see this one now. So this height will not change. This h will be there, but y is what? Continuously will be variable. Able to understand? So what you should do, the level of liquid will be falling continuously. The level of liquid will be falling continuously, and you should move the block. Okay, as the level of liquid falls, what will happen to the range of the jet? The range of jet is going to change. For that purpose, you should displace the block. So he's asking what speed the block should be moved so that the stream will always hit the blocks. You can see this position earlier. Are you not seeing any displacement? Yes, there's a displacement, no? The block was earlier here, now it has come to this one. So it has undergone displacement. In that time, what happened? The level of liquid in fact decreased. Earlier, this was the level of liquid. If you can understand this diagram little bit, it will help you to write equation. That's what I'm trying a lot here to impart that idea. Okay, fine. So now how to get the dy by dt? That's all. How to get the dy by dt? Let's come for that one. What amount of liquid that emerges per second, that much of liquid per second should decrease in container. Common logic. For every 1 second, 0. Let's say the case 0.1 liter per second. For 1 second, 0.1 liter will emerge out. How much per second the amount of liquid should decrease in container? The same. Say how much of liquid emerges out here, that much of liquid what pen should decrease here. So we'll agree this. So now here we'll introduce now A into V. What is A into V? A into V1 should be equal to A into dy by dt. This A into V1 will become flow rate. Look at the units of this. We'll call that as flow rate. What are the units for this one? Area of cross section, how much? Meter square. Velocity is how much? Meter per second. So cubic meter per second. So there's nothing but amount of liquid per second. So what are the units for this one? This Q is called as flow rate. Meter cube per second. What does it mean? The amount of liquid emerging per second. Amount of liquid emerging per second. So what amount of liquid emerges per second here? That much of liquid per second should decrease in the container. That's what we say flow rate. We say flow rate here. So now area of cross section into velocity of efflux at all should be equal to dy by dt. Why dy by dt? Decrease in level of liquid into area of cross section. So do we know V1? Yes, we have value of V1. We have value of V1. So dy by, so I'll substitute all this one. So this will be A 2gy A dy by dt. So what is needed now? So this is equation 1. So put equation 2 in 1 or call this is 2. 1 in 2. So what is the velocity of the block? Root h. This will be A root 2g by capital A. So this should be the speed of the block. So we have all the information substituting, we'll get the speed of the block. So what you should do, you should move the block with a constant speed. So what is dy by dt? What you should call rate of change of level of liquid in vessel. Able to understand? No, 1 meter per second. Yeah, fine. Okay, flow rate is what you assumed it. From where this flow rate? I think in equation of continuity, what will be the flow rate at holes 1 and 2? Should be same. A1 V1 equal to A2 V2. The equation of continuity only we have applied it. Between what? Between this hole and the broader and the opening of the vessel. So the tube will be like this. Why you need thrust force? What is the use of thrust force? This container is fixed no here. What is the necessity of thrust force? Container is not movable. Only the block is movable. See, you should not do one thing, just take Bisleri bottle, put hole. See, I really want to understand. Take Bisleri bottle, cut that upper part. I think you can really work out. This will be Bisleri bottle, no? Sir, I'm finding very difficult. Okay, no problem. Take Bisleri bottle. This will be the thing, no? Cut this much. Then you get a vessel of cylindrical container shape. Then you take pin or something, put hole, fill up a liquid, put hole. Then you check it. You keep it and do marking. So when you make hole at different points, so where do you get that one? You should have a plaster to close holes also. If you have 5-6 Bisleri bottles, okay, fine, well, good. Okay, now you make a hole. Then you take eraser something, keep it on the ground. Then as the level of liquid falls, so we know what will happen to the jet. So the jet, what will happen, the range will decrease, no? So for that, you should move the block. That's for this question. If you really want, you can try it in your home. If a threshold, see, one thing, common sense is needed. Everyone is asking thrust force. Thrust force, when do it will come? When things, something related to that. Tell me what is use of thrust force here, anybody? It's a very serious question. Okay, what is use of thrust force? Okay, you want to calculate. I'm not against it, but what is use of it? Nothing more. Container, if it is moving, container moving, thrust force will come into picture. Container is about to move, container moving, thrust force will come into picture. Most of the problems, container will be fixed. Only if the container is free to move, okay, then you bring thrust force into picture. Okay, got the idea?